An introduction to low viscosity fluids. Water, being the basic necessity of our daily life, is used by us for multipurpose, from drinking for quenching our thirst to bathing, cleaning, cooking and other daily activities. Similarly, we use fluid like honey in our regular or monthly diet plan because of the benefits we get from multi-nutrients present in it. The most basic thing you must have noticed about these fluids would have been the difference in their speeds. The question, why water flows so fast while the speed of flow of honey is too slow as compared to water, must have aroused in your mind. The observation in the first situation, where the main subject is water, arises as the low inner resistance of water to remain in motion led to its momentum transfer very easily, inflicting it to shear it without any difficulty, and the quick flow of its molecules described as low viscosity. On the other hand, honey is a dense, dark-colored, and semi-fluid substance with a very high internal resistance to flow, barring the momentum transfer causing it to flow sluggishly and resist deformation, described as having high viscosity. Let us now take another instance to make it more suitable to acknowledge. Take a bottle filled with milk and then pour it into another container. You will observe that the speed of milk that is flowing out of that bottle is too fast, and it barely settles on the surface of the bottle or the surface of the neck of the bottle. You will also observe that the contact between air and milk is for a concise duration. Now, take another similar bottle filled with glycerin this time and pour it into another container. You will observe that speed of glycerin coming out of the container is too slow compared to the speed of flow of milk coming out of the bottle. Also, a good amount of glycerin settles on the surface of the bottle while pouring out. You will also observe that the contact timing between the air and glycerin is too long when compared to that of milk and air. In the case of milk, after coming out of the bottle, milk directly takes the shape of the container, while on the other hand glycerin barely takes shape, and that too after a very long duration. This clearly shows that the viscous property which helps in resisting the internal momentum in glycerin is very high, while in milk, it is very less as compared to each other. Fluids having low internal resistance due to their weak intermolecular forces, resulting in easy transfer of momentum, causing it to shear easily and making its molecule flow quickly, described as low viscosity fluids. Different ways to determine the viscosity. The viscous property or viscosity is one of the properties of fluid that can be determined by using distinctive approaches and various methods. Whether a fluid is more viscous or its viscous property is less compared to others is being kept on record by these approaches. These types of approaches can easily be done by oneself or by using a standard measuring device which is basically made for measuring viscosity, i.e., a viscometer. Method 1. Done by oneself. As observed and known by everyone, the duration a fluid takes to flow differs to some or a large extent. For example, if we pour out milk from one vessel to another, it will be transferred to another vessel, acquiring the shape of that vessel, and that too in a short period. Now, let us do the same thing just by replacing milk with tomato sauce. The total time taken to be transferred from one vessel to another by tomato sauce, compared to the total time taken by the milk, will be a lot more. Moreover, if you can observe that the interface between milk and air when compared to that of tomato sauce and air. Method 2. By using viscometer. Since the past times, various kinds of methods have been adopted to determine the viscosity of a fluid. Also, many different kinds of viscometers, a device used to measure the viscosity of fluid, have been developed for measurement. Also, among them, many are still in use till present. In general, the history of viscometry is very ancient and too vast for anyone to explore and acknowledge. The same is for viscometer, which is still being technically developed and is too vast to discuss after its invention in the past. Now, we know that the interparticle forces, which include the molecular attraction within the solution and the friction due to momentum resistance, determine the viscous property of a fluid. The analysis of base principles on which viscometers works to determine the viscosity is categorized into two different forms. Kinematic viscosity, which is actually a term given to the physical property of fluids that can be calculated by finding the ratio of the viscous force of the fluid to the density of the fluid. Equals, / The SI unit of kinematic viscosity described in fundamental unit terms is m2/s. It is also termed as Stokes, St, which is a name given after the surname of a great physicist Sir George Stokes. Dynamic viscosity, which is actually a term given to one of the forms of viscosity calculated using viscometer. It is the measurement of tangential force or shear stress calculated per unit area, which is required for the moment of one horizontal plane with respect to the other horizontal plane. Equals, / The SI unit of dynamic viscosity described in fundamental unit terms is kg/ms. It is also termed as poise, P, which is a name given after the surname of a great French physicist Jean Poiseuille. As we have already acknowledged about low viscosity fluids, let us now move a step further and get to know some examples of low viscosity fluids. Water, milk, brake oil, ethanol, engine oil. Some examples of low viscosity fluids. Water is a transparent, odorless, and colorless substance found in abundance all over the earth. It is an essential requirement for all living beings to survive. It basically flows in the liquid state in the water bodies, while it is also present in the form of ice at the North and South Poles. Moreover, it is also spread all over in atmosphere in gaseous, vapor form. One molecule of water comprises 3 atoms, which consist of 2 atoms of hydrogen and 1 atom of oxygen. These atoms are held together by a strong covalent bond. Billions of molecules of H2O altogether make bonds with each other to form a single drop of water. But the molecules are relatively simple and small, causing a narrow stress relaxation time spectrum, due to which water has a low viscosity. Milk is one of the daily used products as well as an ingredient for different milk products and other food recipes. Basically, milk is a heterogeneous mixture whose viscosity depends on the composition and the physical state of its colloid. This dependent viscosity varies according to the given temperature and pH. Brake oil, as we know, brakes are among one of the most important parts of a vehicle, keeping the point of safety. They work on the principle of Pascal's law of hydraulics and thus are called hydraulic brakes. These hydraulic brakes require fluid for them to function, which are called brake oil. These brake oils have low viscosity, which is very helpful while braking suddenly in extreme situations. Ethanol is the chemical name of alcohol that people drinks. Its chemical formula is C2H5OH. This ethanol is a colorless liquid like water, but has a very pungent smell. Also, it is a very volatile and flammable substance, which is used for multi-purpose like the manufacturing of drugs, polishes, cosmetics, etc. The viscosity of ethanol is although very low but a little bit more than water. Engine oil is a fluid that is used in an engine to coat the moving parts of the engine. Since the engine has many parts inside it which rub each other while functioning, this harsh rub causes friction which can even damage the engine parts, leading to a breakdown. The engine oil coating, which has low viscosity, used here so that the parts don't grind and break down. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.